hear me well? Okay, so I'm Oleg Grib. I manage security for Samsung IoT Cloud solution. I'll talk about this a little bit later, about the solution itself. It's funny that I was attending the most session today, and people were coming in saying, "Hey, I'm not a security guy. Don't assign a blame. Take it easy." I wish I could say the same, but I can't. I am a security guy, and I've been working in security for the last 10 years. So feel free to assign a blame, and do not take it easy. So Sanjay and I just returned from AppSec USA conference, and we've heard there a great many talks about security tools and security automation. And I was really excited about all that. But at the same time, you should remember that security tools are not everything. Security code is not everything. There is something else that you need to implement to make your security program sound, right? And I would say that your security program just as good your integration with existing SDLC is. I want to take a little bit a retrospective look at what we had 5-10 years ago and how we transformed it to achieve our current goal. So if you look at what we had 5-10 years ago, SDLC was very much waterfall, right? We had all the steps clearly defined, business requirements, architecture design, software development, testing, deployment. And I think at that time, our security process was integrated well with that old methodology. We had the luxury to have 2 full-day threat modeling interviews with getting a lot of people involved. And I'm talking about business, developers, database administration, operations, QA, everyone was available, and we would go to their site and talk for 2 full days just to understand the application well and to ask all those security paranoid questions and to create a threat model based on that. So our threat model itself was very formal. We were using this old concepts like Dread and Stride. I'll talk about them a little bit. And we even created our own scoring system to make it even better, to assign a number. After our threat modeling exercise was completed, we would go to 2 to 4 weeks of penetration testing. And it was cool as well. The only problem was that, again, it required a lot of time. After all of that was completed, we would generate documents, separate documents for executives, other documents for developers, and then follow up on details to make sure that everybody understands what needs to be done and what the biggest risks are. So returning to this Dread, I'm not going to talk much about this. If you want, you can Google it. I'm showing it here just to say in the very end that we are not using it anymore. But the good thing about Dread was that it looks very scientific, right? And it has categories. The bad thing about Dread is everything else. Because, no, really, because what they require you to do here is to assign a risk for each category, which as much guesstimate as assigning a risk to the whole one, right? So that's why it's just, I don't know, not useful anymore. With Stride, it's a little bit different. I know that some people still use it, and this is a way to categorize your threats when you do threat modeling, for example. The problem with this approach is that these categories look too abstract to me. And when you do threat modeling for a few years in a row, you would start thinking in different categories, like authentication, authorization, access control, database security, and so on, so forth. So this will die as well eventually. And if you look at other approaches, even CVE database, which provides you real cases, which are closer to, which have more bearing with reality. And if you add the fact that most scanners generate those CVEs automatically, then it's not a brainer. This one is not going to survive either. Then on top of that, we did even more cool stuff. So after we had Dread score assigned, we started evaluating security mitigation controls. And if you see in this table, you can see that if a Dread score is high, for example, 10, but all controls implemented well, then a residual score will be 0. So we introduce like yet another thing, which is residual risk, which is coming from any vulnerability. And vice versa. If security controls not implemented at all, then even small dread score will bear a significant residual risk. Moreover, we did cool things which are called like heat map. In this heat map, again, we had 2 dimensions. On the top, you see the common risk, which is coming from application. On axis Y, you see how well the controls, security controls have been implemented. And if your application is here, then it was like very bad. If it's here, this is like actually a desirable quadrant. After all this like threat modeling was completed, we would go to penetration testing. And at that time, like we were looking at automated penetration testing down. We were thinking, you know, like the most important bugs are always found by manual testing. And this is true, of course. This is just one example of good findings. We were doing some manual testing for trying to understand if a random number generator is good or not. So we just sample 1,000 values, plotted, and it's obvious that it's not, right? Then we tracked it back to the code, found the reason, and fixed it. So this is just to demonstrate that we were doing like really cool things, and our security assessments were more like a research than a routine job. So this is, I just want to summarize old approach to security, application security. So we generated apparently a huge document, like XLS files. We wrote nice executive summary, and we presented details to developers. We had all these cool visual tools to make it even better. And then we worked on remediation with developers, the process that we called nagging. And everybody understands why, right? Because developers always have something better to do than security. So it was like very much like nagging and us and them model. We didn't intervene too much in their domain. They didn't intervene too much to our domain. So this is how it goes. And when we really wanted to escalate, we would use our like weekly security dashboard that we presented to CTO to make sure that teams actually have priority assigned and they follow up. And everything worked well until Big Bang happened. And by Big Bang, I mean 2 things. DevOps and Agile have become prevailing methodologies everywhere. And we just were sitting like our small security team, looking at all the Scrum projects flying around like a bugging mosquito. Our head was spinning, and we realized that we cannot do it all the way anymore. We need to change. So now before I talk about how we change, I want to talk very quickly about our product. So our cloud solution for IoT devices is called SAMI. And core products are API-based. We also have web applications which are built on top of that. Most importantly for us, that everything runs in agile mode. And we just need to make sure that we are enablers, not disablers, that we are running with the same speed as developers. You can find more details here. Or send me an email. I will answer all questions which are related to the product. I don't want to talk too much about this. So we had no choice. We needed to switch from waterfall to agile. We needed to do it fast, otherwise we would become irrelevant. And if you look at new agile reality, this is how it looked like. So we didn't have 2-4 weeks for security purposes anymore. Nobody cared about all these formalities, about all the stride, dreads, residual risk, heat maps. Nobody cared about that anymore. We didn't have a possibility to get all people together. It's simply not possible physically because the team is distributed. We have people in South America, we have in Europe, we have in Asia, we have here, of course, and it's just not possible. Finally, like we couldn't even get an environment dedicated for security testing for 2-3 weeks. It was not feasible either, because developers are doing some QA tests, and after it's tested, it should be released immediately. So it means that we needed to run in parallel. So other challenges which are coming from API nature of our products, that it's not like a web application where you can do crawling, spidering, all those things. You are dealing with URL, which represents REST API call, right? So, and there is only so much you can do with this. You can test only this URL at a time, no matter how automated your tool is. So what you can do, of course, you can write manual test for each and every REST call, right? But considering that we are not like very big team, right? It simply doesn't seem to be feasible. And we actually like about this one, I think like we have a very good approach that you can use in your organization. So basically what we are trying to do, we are trying to utilize thousands of unit tests which were created by QA team, which is probably 5 times bigger than ours, to run all our security job in automated manner. Sanjay will talk about this in details. So aggravating factor. Security testing is not exactly a QA. In QA, everything is like very much deterministic, right? Like if it's a bug, it's a bug. You don't need to explain much. You just export it to Jira and it's done. In security, you have a lot of false positives, and if you do the same, you will annoy a lot of developers, right? So you don't want to do that. So you not even like if you know that vulnerability is real, you still, in most cases, you need to do a triage to define a severity correctly. And because severity is used to assign a priority, so if you didn't assign the priority correctly, again, you will screw up your process. So taking into consideration all those challenges, our hypothesis was that we actually need dashboard. Dashboard not for executives, but for us, for security engineers. And we need this dashboard to support import for all possible vulnerability sources, on one hand. On the other hand, we needed a dashboard that would allow us to export vulnerabilities easily to a bug tracking system, to automate process of communication between security and developers. We also were thinking about running all these scans in automated manner as much as possible, but we should also have capability of manual testing, because for new features and new products, we still need to do that. So this is how our solution looked like. We found this Threadfix as our like core product in our security architecture. This is open source, this is free, and it has a good team which supports it. We even contributed to this open source project, and it was published, accepted by Threadfix. Then on the left side, you see all the scanners and all vulnerability inputs that we use. We use OWASP ZAP, we use Burp Suite, and they run as a scheduled jobs. There is no any manual intervention there. They run the jobs and they upload everything to Threadfix. Vulnerabilities are stored in MySQL database after that. We do manual testing, but only for new features and products. And we have some custom tools. Custom tools are intended to do targeted testing for the applications that we know well, and we know what kind of problem we may face. So we're writing sometimes our tests as well. Threadfix can send notifications through email about new high and medium vulnerabilities found. Most importantly, like the most important part of this architecture is like two people on the top who are actually monitoring this dashboard to make sure that we are not exporting any false positives to Jira and that all severities are assigned correctly. Sometimes we need to talk to DevOps team when they don't understand what the nature of vulnerability is or how to fix it, but it's not very often. So this is like at high level what we have in place now. Now I turn it over to Sanjay, and he will provide more details about this.
Thanks, Oleg. This is Sanjay. Sorry about that. So thanks, Oleg, for introducing me and covering the first part. So my name is Sanjay Tambe. I work in same group as Oleg, working in the cloud platform called SAMI, and that works on Internet of Things. Our teams are spread across the whole world actually, all over the continents, multiple teams. We are only 2 of us managing the security of that part, and multiple people in QA team. So doing security the old-fashioned way, as Oleg suggested, was not a solution. We had to evolve and introduce security automation in our process. So before I go too far, I want to ask you, how many of you are actually using security automation in your environment? Okay, few of you. Great. So one thing that you can take away from today's talk is, if you can go back, if you want to introduce security automation, I think that something would be very helpful. We have introduced security automation using a couple of open source tools. And what I'm going to show you before I talk about how you can implement security automation in your environment, step by step, I will show you how the final product looks like. And then we can take a look at how useful it is, and then you can start based on that.
Hi, my name is Sanjay Tambe. I work as a security architect in the Samsung SAMI team.
Sorry about duplicate introduction.
We are responsible for creating a secure cloud-based platform for IoT development. In this video, I will be demonstrating the final stage of security automation, how it will look like, and then later on, I will show step by step using the PowerPoint how you can implement the security automation in your environment. So as an example, I have created a fictitious team called accounts with 2 fictitious applications, payment regression and payments. And even it's not a payment application, actually I'm using WebGoat from OWASP. So the way it will work is, after you go through all the steps in implementing automation, and you start the automation, let's say you want to scan a payment application on a daily basis at a certain time in the morning or whenever, and once it is done, it sends an email alert on a timely basis whenever you say you want that alert to be sent, and based on whether it's a high risk issue or not. And then you receive the emails. Let's say we have received an email with a high risk issue. So you come here and look at the scan results for payment apps, and we find that yes, there is a SQL injection issue, cross-site scripting issue, and so on. So let's see how you can review the SQL injection issue and do something about it. So for example, after looking at the SQL injection issue, you find that this issue must be fixed by the developers. So we go back and take the action of creating a defect in Jira. So let's call this a bug, and you type this as a SQL injection. And then fill out rest of the information and as required by your issue repository. Now these fields are configurable. I won't go into details in this video, and then you can click the submit. I won't be submitting this because it will create this issue in our real actual repository. So I will just cancel this for now. The second thing you can do is mark this issue as a false positive. And once you mark it as a false positive, it won't appear in future email alerts or any email reports or so on. So that's the second part. Third part I wanted to show you was, let's go back to the application payments, and you can also upload the scan manually. So we won't be using this approach for those applications for which we have implemented security automation. But I just wanted to show you that this option is also there for uploading your scan results in XML form. The fourth thing I wanted to show you was how you can configure your system for email alerts. So you come here and configure alerts for your teams. So I have configured my email alert to be sent out at 8 a.m. in the morning for accounts team, and when the severity of issue, any of the new issues is medium or higher, and so on. And you can set up the email address and so on. So that's how you would receive the alerts. And once you receive the alerts, as I shown before, you can come here and review the findings and submit the issue in Jira and so on. So those are the things that I wanted to show you as a part of security automation, how it will look like. Thank you.
Okay, so that was the demo that I just wanted to give you briefly what we are looking for at the end. So the thing that I'm going to explain to you is step by step what we did. This process was implemented using a few open source tools as well as commercial tools. So for this purpose of this talk, due to shortness of time, I'm going to only talk about doing automation using only Zap, OWASP Zap. Many of you, I'm sure, are familiar. So all that you need is an AWS, if you're doing it in Amazon Cloud, it's AWS instance or a VM or even a physical machine. That's one of those three things needed. And then Threadfix, which is an open source, which will actually be used for collaborating all the scans and generating email alerts, reviewing scan findings, and as Oleg said, and filing issues in Jira issue repository that we use, and scheduling the scan. So I'm going to talk about how first of all we need to configure Threadfix, which is I have instructions for downloading and all that. This is complete thing that you will need but your environment may need different configurations. So I won't go into details. These slides will be available for for you later on, so no need to take any notes or anything. So you have to can install Threadfix from one of those locations and configure it to run on one of the ports, 8080 I have taken as an example, and log in with user ID password. The next step is to create an account. Let's say we have multiple business teams with multiple applications under them, and you may also have APIs. So I'll also talk about variety of REST APIs that you may want to test in your environment. So I'm going to add initially only the security folks as the users in your team. So that may be whatever 2, 3, 4, whatever you have, or even more. I mean depending on size of your organization. Some groups have 30, 40 security folks. But I would limit it to security because initially you want those alerts to go to your security folks. Add them all. Then next step you will do is add the business team itself. So I would add initially an accounts team, I'm calling that, and I will create a couple of applications under that team later on. I'll just go quickly through this. Then I'm going to create a payment application under this. As far as information is concerned, it's not critical. Those prompts are self-explanatory, but I just wanted to give you the steps for the sake of completeness, basically. And then once you create the payments add an application, it shows up as payments app under accounts team. And then you also configure it to use the defect tracker, because your ultimate objective is that the security person will review the findings and submit the issue in your Jira. So the only valid issues that the development team should be fixing should go into Jira, and no false positives. That's your objective. If you have false positives, you lose kind of credibility with the dev team. So that's what we are trying to avoid here. Next one is a visit application in Threadfix. And once you create that payment application, we just want to note down what the application ID was. So in this case, it's 31 over there in the URL. I know this is, but I'm just giving you so that later on you can, when you upload the scans, you are actually uploading it to scan application number 31 and through command line. Eventually, all the steps will be in a shell script. And I will have the example of that shell script as well, and you can modify it in your environment. Next one is set defect tracker for each application. So we have only one application, so we set the defect tracker to one Jira. You could have Bugzilla and others as well. enter login. So you want to set up the login as a separate. You should not use your own Jira or Bug Tracker login. You should have a separate one that issue came from Threadfix. Install Zap. Now, we install Zap in two ways. One is to use it in a headless mode on the VM server or AWS instance or wherever you're wherever you installed Threadfix. You can install one there for headless version and one on your laptop or desktop, whatever you use, to create the session file. So I don't know how many of you are familiar with using Zap. Okay, some of you are. Zap is an open source tool, and there are several YouTube videos available on YouTube, basically, how to configure Zap in various ways. So that will be a good one. So those who want to use it, it's a free tool from us. So the two were, I have only downloaded one version, but you can upload it. You need to upload it to the server as well as one for your desktop for creating the session. So just a Zap UI. Just wanted to show you here. So now we are going to configure scans for web applications. So I'm going to do two things for this purpose. For completing the security automation, part one is basically configuring the scans for your web applications. And the second step is leveraging the QA. So QA, we have QA team that is larger, like 5 times the team of our size, and they have built thousands of test scripts testing the APIs and web applications and so on. We're going to leverage those test scripts as well. So we have two types of configurations, and both will be part of our daily security automation. So we configured all those tests to run on a daily basis, and the alerts are sent on a daily basis. So this one is basically you configure your Threadfix so that you can upload it to upload scans from command line. And you need to provide the API keys and the REST URL, which, this will, if you set it all default, the URL will be same, but your key will be different. So you have to find out from Threadfix what your key is, and it's very easy to find from the menu itself. This is a shell script that we created for scanning a web application, and it has got all kinds of parameters, but the main parameter that you want to take a look at is you're running Zap in a headless mode. So you need the CMD and session options, CMD option, and then the session is for the actual session that you create that stores the authentication for your web application. So that information is stored, and you create it on your desktop and upload it to the AWS instance or VM or wherever you have. And once it is in the AWS, in your instance where you're running the Threadfix, you can run it from anywhere, but you don't want to run these scans, the automated scans, on your machine. No machine should be tied up. Ideally, it should be somewhere else, in a network so you don't have to keep your machine on. That's the idea. And then it runs the scan and then uploads it to it creates the file from the first one in an XML format, and you just upload it using the REST API from Threadfix to Threadfix server. You could also do cron jobs. So you could set up cron jobs that run on a certain time. So either you can run it like every day if you are deploying more often than that, every 6 hours, or less often, every 3 days a week or something. You could do those kind of things that happen automatically. Alternatively, you can use one of those open source cron job schedulers, and those are pretty easy. You can start a scan job on demand, as well as you could say, hey, I want to run it on every weekday at certain time, and so on. You could do all kinds of jazz on that. Bscan is another thing that we used. I just wanted to give you information because for the sake of completeness, although I'm not going to show Burp, because Bscan we use with Burp for automation, but it's a very useful tool that basically allows you to use Burp in a headless mode using Ruby extensions. And it also allows custom tests in the scan. And the usage is very easy. I mean, it's a simple command as jruby -s bscan -c config and so on. So it's a very simple command, simple way to use Bscan. The way it works is you start it as a proxy and let all the traffic go through it, and then it will when all this traffic stops for a certain period of inactivity, it stops and creates all the XML reports that you have suggested. It can work in an auto proxy mode. It is highly configurable. It can override some of the burp settings as well as custom settings. And we use version 2.01. 3.0 is coming. Oh, we already got, okay. So we already uploaded 3. Configure security testing using QA regression. Now, this is the one thing that I would like to leverage, QA basically. And the reason for, as like mentioned, over the years, QA team has built several test cases, probably thousands in many organizations. Security team can review what they did. So we use them as a sort of, happy path use cases, and then use those use cases for security testing. And they can also be used through a proxy, such as burp or zap. Now, I'm going to show through zap, but it can be easily configured for burp. So we add another application called payment regression. So this one is for the regression part of it in Threadfix. Then start the zap proxy. Now these commands actually we had to play with zap for several times to get it right, get it run correctly and all that. Like for example, the XMX, we had to use 2 meg, 2048 meg for memory and all that. So that you may have to do some settings. These tools, these commands will be available for you, so for download. But start the zap proxy, and then the next one is configure your QA regression. Now QA regression by default, they could be using backend, Selenium backend or Silk or whatever. You may just want to have them use a different proxy. Instead of your default company proxy, use it to go through your zap proxy. That's the only change they have to make, and that's pretty easy for them to make. And then use the command such as following. We are using Maven. So use the command something like this. Now your command will be different depending on whether you use Maven or not, but it doesn't matter. There is a command that you can use to run your regression. And this regression, by the way, I forgot, you should run the regression on a box, basically, not from your computer, ideally. So that it can take several hours. Next one is at the end of regression, use the curl command from zap, because to create the XML file. So the key and everything is provided during the startup. So you can use the same setup to create the XML file and upload it to Threadfix using this command. Now this is it uses the REST API from Threadfix. And the last part is basically reviewing security findings to create the ticket. So this is the main objective of security automation, is to run the scans automatically and review it, have a security team review it. That's where the value add is, right? Where security team value add is basically not for doing routine work that can be easily automated. The value add is actually reviewing some of the findings, some of the high-risk findings, and coming up with a severity, when they should be fixed, talking to the developers if they don't know how to fix it, helping them with fixing those issues and so on. So that's where the value add is, and that's what we want to separate out, have the objective of security automation. So as I showed you before in my video, you can use the actual findings as shown by Threadfix and review it right here. You have enough information. Right now we are using only Zap. Now I'll show you. There is a slide that the Threadfix can be used with other tools also, commercial tools as well as open source tools. We are using Threadfix with multiple tools actually. We are also using the dependency tool from OWASP for scanning third-party jars. We are using Burp, Zap, and so on. Create a defect, as I shown in the video. Create the defect in your issue repository. So you are only filing issues that are important, that should be fixed, and update all the information that you need for your ticket. This is not a plug actually. Just wanted to say for the sake of completeness. Threadfix supports all these scanners for now. There are once you start your automation, depending on start implementing security automation, your choice is quite vast actually. I mean, you can extend it to variety of tools. And with that, I will give it back to Oleg.
Thank you, Sanjay, for the details. I just want to round up it quickly. So this is how our security transformation cheat sheet looks like. So this is transformation from the old style security to the agile. So instead of doing this 2 full days threat modeling meetings with many people involved, what we do now, we just participate in discussions through collaboration tools like Confluence or others. And when developers discuss a new feature, new design, this is a right place for security to get involved. Then from very formal scientific or pseudo-scientific, as I call it, threat model with dread, stride, residual risk, and heat maps and all that jazz, we just ended up with recommendations that we put in directly to Jira and making sure that somebody follows them. Instead of dread, residual risk, etc., we're just using simple high, medium, low models that everybody understands, not only security. Stride is gone as well. We are using CVE database. The good thing about CVE, as I mentioned, is that it's automatically assigned by scanners, and we don't need to do anything to make it happen. Manual pen testing for everything is gone, of course. We don't have resources for that, but we still try to do manual testing for new features and new products. Expensive commercial scanners are gone. So like in my view, all these tools like OWASP, ZAP, and BERT, they're not worse. In some ways, they're even better. Another important change, we do not use docs and PDF anymore to generate reports. Instead of that, we are using the tools that Sanjay has demonstrated with directly exporting our information to Jira. And nobody runs scans manually, except if this is like a manual testing, of course. And we rely on our automated batch jobs more and more. Coming to conclusion. So apparently you cannot do your security as you did it 5-10 years. You need to be aligned better with your SDLC. You need to automate security by using all the scheduled jobs, out of uploading findings to dashboard and so on and so forth. Most importantly, you still need to use security professionals to differentiate between false positive and real findings, and you need to assign the priorities correctly. The last one is probably the most important. Do not feed false positives to developers, otherwise they will get angry very fast. And I can even formulate it shorter. So stop firing buttons that nobody will have a push. I've stolen this phrase from a Lean Startup Conference 2013, and it's applicable for security as well. I mean, if nobody cares about this pseudo-scientific stuff, then why doing it and spending time on all this stride, dread, residual risk, heat maps? Nobody cares, so stop doing it. The next one is, this is interesting. So I heard many new buzzwords like security as code, security as service, and so on. I would recommend to stop using those as well, because if you use them very frequently, you can easily set up a false expectation for your executives and create confusion among developers and security engineers, because they would think that to solve all your security problems, you just need to write a lot of code. No, it's not going to happen. Write as much code as you want, but don't forget about security artists, because they're the only people who can make sense of all that overblown output generated by security scanners and other security tools. So there is no way you can take people out of this equation. The last one, I like this one from today's keynote. So I think this is very much what I'm saying. Security culture is people, and you cannot automate everything. Okay, I think that's it. Thank you for coming. If you have any questions, go ahead and ask them. Or you can follow up us on Twitter and ask your questions there.